Good morning, dear students. Welcome back to the virtual classroom. So once again we meet here to discuss from the previous topic, that is classes and objects. We're discussing about classes and objects, and just I gave you an introduction about classes and objects. With that, I gave you two examples. The two examples were to find the sum of two numbers, as well as the other example was to calculate the simple interest. So we are going to continue with the discussion on class and objects. Last class we had discussed about the inside class definition. So today we will be discussing about outside class definition. Once again, to re-emphasize what we did, I am going to write the syntax again. So syntax will be class, and there is a class name, open a flower bracket, and then private. Hope you remember we had written this, private, data member, and then member function, data member and member function. So this last class, while writing the syntax, I had written member data. So to have a difference between these two, I am saying as data member, and the second member is the member function. Private will be the access specifier. Three access specifiers are there: private, then protected and public. So protected access specifier, once again we have data member and member function, and then public. So public, again data member, member function, data member and member function. Then close the flower bracket and a semicolon. So when we write the members of a class, as I said before, we should be writing under access specifiers, because when we access members, we will be using the object. We are going to use object to access the members, and these members, as I said, will be having the data member concept and the member function. Data members, in the previous class we had written few normal variables, and under public we wrote the member function. So both were written inside the class, that is inside class definition we call. Today we will be discussing on outside class definition. With that, one important operator, that is the scope resolution operator, we are going to discuss. So this scope resolution gives the scope of the member function when it is defined outside the class but declared inside. When we define it outside the class, now it should be belonging to any of the class. So scope resolution signifies that the member function will be belonging to a particular class. So we will be working on the outside class definition, and I would like to take the same example of simple interest. In the simple interest, we know that principal, time, rate of interest, and these are the data members what we took under private. Private also signifies the data hiding. We won't be able to access the members directly which are under private. So we will be accessing the private members through public. So we will be discussing on the simple interest in the context of outside class definition. Outside class definition. In this outside class definition, we are going to take an example. the same simple interest. To calculate the simple interest, we need the variables as P for principal, the initial amount, and then T, time, as well as R, rate of interest. With this, the formula will be P into T into R divided by 100. The value we are going to store in SI. The same example how we discussed in the previous class, likewise we are going to take, but under outside class definition. So I start with hash include. By default, we know we need these two header files, iostream.h and then hash include con.io.h. And then class, we have a class name, simple underscore interest, simple underscore interest, that is the class name. Then I open a flower bracket. After that, I am going to establish the private members. The private members, as we discussed last class, the same I am going to take int P, comma, T, comma, R, semicolon, and I am going to take a float value SI. That is, SI is the variable, and we are going to take the resulting value. And then public, here we are going to declare the member functions. So the three member functions what we had was void get data, void calculate, and void output. So here we are going to write as the declaration of the member functions, and we are going to write the definition outside the class using scope resolution operator. So void, then I say get data, void get data, and then void calculate, void get data to take the input, void calculate to do the calculation part, and the output, that is void output. If you see the three functions here, I have written the declaration part of get data, calculate, output. We are going to define it outside the class. That is, we are going to write its coding outside the class. Now, the three functions have been declared, and I say closing the flower bracket, semicolon. With this semicolon, we continue to write the definition of the member functions. So I begin with void return type specifier, then the class name. The class name what we have is simple underscore interest, and the member function, that is get data, function brackets, get data, open a flower bracket. Here there is a semicolon inside the class, and we write the header of the function having the class name with a scope resolution operator. So the scope resolution operator will be 2 colon. This is the symbol of scope resolution operator. Scope resolution operator. Let us continue with the get data member function. So we are outside the class, and outside we are going to define the get data, open a flower bracket, then I am going to say cout, enter the principal, and then we are going to take as endl, semicolon. Cin will be the principal amount we need to take the input. So we take the variable as P. P accepts the principal amount, and then we go for Cout, enter the time. So enter the time would be for T. So Cin accepts the value for T, and then third input will be for our rate of interest. Enter the rate or rate of interest. So when we take the rate of interest, the variable we use is R, and Cin I take as R. I close the flower bracket. If you look at it, we have declared member function getData. Likewise, after closing the bracket, semicolon, then we have defined the getData member function. So the getData member function has got its code outside the class. So this is the outside class definition. The next member function is calculate, which is under the public access specifier. We are going to write in the context of outside class definition. So the same syntax we are going to follow, that is return type specifier as void, then class name will be simple underscore interest, and then the scope resolution operator, that is a symbol scope resolution operator, and then we have the member function name. The member function name will be calculate. Member function name is calculate, and we are going to write its contents or the code. Here we know the formula SI equals P into T into R. So in getData we had accepted the input. So here we are going to have the calculation part. Write as SI equals P into T into R divided by 100, semicolon, close the flower bracket. So this will be the member function defined outside the class, that is calculate. The next member function is the output, written under public access specifier. So we are going to write as outside class definition. I write again void, then the class name simple underscore interest, then the scope resolution operator I use, scope resolution, then output, that is the member function name. Output function brackets, open a flower bracket. Here we are going to print the output. So I say Cout, the simple interest is, then I close the double quotes operator, then its values supposed to be printed here. So I say SI holds the resulting value after calculation, and then SI's value will be printed here. The simple interest is its value, then I say enter, semicolon. So this will be the way of writing for outside class definition: simple interest, scope resolution, output. After that we are going to write the void main. I have rewritten the program again so that we could be understanding the sequence of the control. So simple interest, that is the class part what I have written here. So it will be the member function declaration part. getData, calculate output. After that I have written getData, that is the outside class definition. getData, then comes the calculate, then comes the output. So I have rewritten the program. Please do take down. Now we move on to the void main. So main function, open a flower bracket. Last class I told you how we need to create the object. When we create the object, that object will be created as per the class name. So the class name will be simple underscore interest, and I take the object as yes. Yes is the object. Then I would like to access the members. This is the same as the previous example, but the context here is, for us, we need to understand that outside class definition. Simple interest, yes. Then I continue, S dot. The member function we are going to call is get data. So S dot get data, S dot get data, then S dot calculate, S dot calculate, then semicolon, 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 then we have S dot output, S dot output, S dot output, function brackets, then I take as get ch, then I close the flower bracket. When we look at the whole program, let us look at the flow of execution. As I said, the control first executes the main, then there is an object creation. We have S dot get data. So S dot get data execution moves on to get data, then executes for the input, accepting the values for P, T, R, then moves back, calculate, that is S dot calculate, S dot calculate, member function will be accessed, then calculation part, then after that the control comes back, output, then output is executed, comes back and ends the program. The point here is scope resolution operator. Scope resolution operator is used when we have outside class definition here. Scope resolution, scope resolution, scope resolution. That is outside the class definition. This scope resolution signifies that this member function, get data, calculate, output, they are belonging to the class simple interest. That's the reason we write its declaration part inside and the definition part outside. In future classes, we have a concept called as inheritance. In that inheritance, we will be writing more than one class. When we write more than one class, example I am giving you, there could be chances that we write one more get data. That get data should be belonging to a particular class. That point of time, we need to know that this get data belongs to simple interest, or the get data what we write for another class. Some other class we may have another get data, so we need to mention its particular class name. Hope you are understanding me. So the scope resolution tells that this get data will be belonging to a particular class, but provided that we should be writing its declaration part inside the class. That is, we write void get data, function bracket semicolon, and when we come outside the class, we are writing its class name with a scope resolution signifying that get data belonging to this particular class. So this is the concept of outside class definition. We discussed about inside class definition in the previous class. The previous class, in the lecturing class, when we discussed, we wrote the definition and declaration together inside this. That is, opening a flower bracket of a class, closing a flower bracket of a class. Within this, we wrote void get data, the whole coding part we had written inside. Why there is a difference between inside class and outside class? The inside class definition, we have to write simple programs. When it comes, there are a few complex programs we have. That is, when we use a for loop, that becomes a complex program. So these complex programs, we may not be able to write inside class definition. So we need to adopt the outside class definition concept. that point of time we will be using the outside class definition, that is the complex program. When, for example, we use follow, that follow we will be able to execute or work on the nature of the program, the complex nature of the program, only outside the class. That is outside class definition. This is the difference about inside class definition and outside class definition. Today we discussed about outside class definition. Please do compare with the inside class definition concept of the previous class. So you have a comparative note and you can compare both about inside class definition and outside class definition. Take a sheet of paper, write both. That is how we wrote simple interest as inside class definition, and now I have written about the outside class definition. Please do write both, compare both. So we will be working most of the practical programs on outside class definition, because we will be using scope resolution operator, one of the important operator to be used when we work on outside class definition. Dear students, I have written few questions for you, and please do answer these questions, take a snapshot, and there is a link provided for you to answer for the queries. So please make sure you're going to write down. The first question is, what do you mean by outside class definition? What is the symbol? That is, we discussed about scope resolution operator. So what is the symbol? I have written only the symbol called. Then what is the significance of the operator? Again, I have not mentioned as scope resolution operator. You need to write what is the significance, importance of this operator. And the same example you can write an example program to illustrate outside class definition. At the final end, we have why it is necessary to use outside class definition. As I said, the complexity, because we can write complex programs outside the class definition. Example I gave as follow. So please make sure that you're going to write all and do answer it. So dear students, thank you. So we are going to meet you in the next class. Take care and have a nice day for you. Thank you.